This next chapter we're going to start off by talking about center of mass, okay, which is a pretty important concept that we've kind of talked about before, but we kind of glossed over, I guess, before, but even though we've really been using it the whole semester. I'll talk about that in a second. But center of mass is basically, if you have an object, it would be kind of like the average location of the mass, generally somewhere in the center, okay? And so let's say if we have like a series of particles, okay, that all have the same mass, then the center of mass would be here at the middle one. Okay, you have mass over there, the average location is right here in the middle. Now, when we talk about complex objects, like the motion of a complex object like a car, okay, this car has lots of things going on. The wheels are turning, it might be moving this way, someone might be rolling the window up and down. There's all sorts of different motion going on. But when we talk about the car, we treat it just as a point that's located at its center of mass, and we do the physics about that point. Okay? And what that allows us to do is to ignore all the other things that are going on and just kind of look at the net motion of all of these particles. Okay, we have wheels, we have doors, we have seats, we have passengers, steering wheel, windshield, all those things. I'm going to say that they're all acting at this point, moving together that way. Okay, which is much simpler than having to take account for each piece of the car, how it's moving. Okay, and so the way that we find center of mass is, and so let's say in one dimension, center of mass is just going to be you add up each position of each mass and multiply it by the mass of that object, and we do this for each object that there is. Okay, going on for as many objects, and we divide it by the total combined mass. So M1 plus M2 plus M3. So if we have maybe two people, one person standing right here and another person standing right here, and let's say that this is position 0, this person's at a position of 4 meters, this person's at a position of -3, and let's say this person has a mass of 55 kilograms, this person has a mass of 75 kilograms, and maybe there's a cat right here at 1 meter. Okay, that has a mass of maybe 5 kilograms. I don't know how much a cat weighs. Alright, and so let's find the center of mass of this system of 3 objects. Okay, well, we're going to use this equation. We'll say -3 for the position of that person times 55 kilograms plus 5 kilograms times 1 meter for that cat plus 4 meters times 75 kilograms for that person. And then we divide this by the sum of the masses, so 55 kilograms plus 5 kilograms plus 75 kilograms. Okay? And what we get is, add all these up, we get 140 kilogram meters divided by 135 kilograms, and so we get a center of mass of 1.037, or around 1.04 meters. So that is the average location of the mass of this person-cat-person system. Now, if these were all one object connected together, this would be the point at which it would be easiest to balance, okay, which we'll learn about in another chapter. But also, this would be the point where if you were to rotate this object, that would be the point where it could rotate the easiest. Okay? So, and that's basically center of mass. We'll give you a chance to practice a little bit, and then that's it. Okay, so let's try one here where we have a, let's say that we have an object that, or a series of objects or particles. So we have a 5 kilogram block located at -2 meters, and then we have a 10 kilogram block located at 5 meters, and then they're attached on like a rod or something. Let's say this is 0, and then we have a let's put a 3 kilogram block at -1 meter. So I want you now to go ahead and find the center of mass. Okay, so pause it, work it out, and try to come up with the center of mass of this system. We have 3 objects all have mass. Find the center of mass of this system. We add these all up. We multiply each mass by its position, divide by the total mass, and we get the center of mass is at 2.055 or 2.06 meters. So probably like right about here. Okay, this would be the average location of the mass. Okay, there you go, center of mass. Alright, we're going to do one more with two-dimensional center of mass, and that will end the video. Okay, so here we have now a scenario with a two-dimensional coordinate plane with a series of particles. Okay, and so what we're going to do is we can say we can multiply each coordinate times its location, right? So we can do it for x and for y. I'll do it for x and then you can do it for y. So for x, we're going to say the 1.2 kilogram mass located at 0 meters for x plus the 2.5 kilogram mass located at 140, and I guess, yeah, these are meters for x, and then the 1.2 kilogram mass at 70 meters for x. Okay, and so we divide that by 1.2 plus 2.5 plus 1.2. Okay, and we work it out. We get about 88.6 meters for our center of mass. Okay, that was center mass for x. Now this center mass is going to have an x and a y coordinate because it's in two dimensions. So that would be our x coordinate. I want you now to use our y values to solve for the y coordinate of our center of mass. Okay, go ahead. So we add them all up. So each of these has a y coordinate of 0. This one had a y coordinate of 120. Our combined mass down here. And we get a y center of mass of about 29.4 meters. We'll put it right there. Okay. And that would be the center of mass of our system. So right there is the center of mass, 88.6, 29.4. This actually looks a little bit different. This would not be the center of mass, that location. At least that's not what we found. Maybe we did it wrong, but that's definitely not what we found. Anyway, let me know if you have any questions on center of mass, and we'll keep working on it in class.